object-oriented programming for class BSSE second. In this lecture, the topic of this lecture is programming example of polymorphisms. We will discuss another programming example of polymorphism, and this example will be a little bit more important and with different functionality of derived classes. In our previous lecture, we have discussed the example of polymorphism with just the different kind of messages, but here we will discuss the different kinds of functionality that different derived classes have their function with the same name but different functionality. We will also discuss the pure virtual function here, programming example of polymorphism. Base class figure. We have a class with name figure. So here we define the figure class coding. Hash include iostream, hash include conjugate attach. Class figure. Here in the protected section we have two variables x and y. The data type of this variable is float, while in public section we have two member functions. Void set dimension. These are the dimension of a figure. X and y are the dimension of figure. So through this function we set the values of x and y. Whichever value is passed to this function, that values are set into the memory of x and y, that is in the memory of that object, that figure object. We have another function void show area. The function name is show area, data type is void. This is virtual function. Here we have only a message, no area computation defined for this class. This class has no area computation. It will purely work as a virtual function and will actually coordinate the different functions of different classes. We will see this show area function in different derived classes, where each derived class will have its own functionality, that is the way of area calculation, because different figures have different formulas for calculating the area of those figures. So this is our base class with the two member data items and two functions, setDim and void show area, which is virtual. That is for base class, this show area function has no meaning, but it will provide the coordination between different derived classes during polymorphism. We have a class triangle, which is publicly inherited or derived with class figures. This class has, in the public section of this class, we have just a show area. We know that if we have a right angle triangle, that right angle triangle will have just two things. That is, we see it here, that if we have a right angle triangle like this, this class has, this figure has a height and base. Let's first base, height and base x and base y. Area of x multiplied by 0.5 multiplied by y. Such a right hand triangle is actually the half of, you may see it, half is blank, half is filled. This filled area is denoted by triangle. If it is whole square or rectangle, then we will get the area of that triangle by multiplying the length and width of the triangle. Therefore, this is the length and this is the width of rectangle. Then the area will be length into width. But this is half, so this length into width is divided by 2 and we get the half section, that is the half area, which is denoted by right angle triangle. Area is, this is length multiplied by width multiplied by 0.5. 0.5 denotes the 1/2, that is half. Half into x into y. This is the area of right angle triangle. So we will calculate here show area for right angle triangle class, and it will display triangle with height x. X is the height and base y. Y is the base. These two values will be displayed, and also using this expression it will show the area of that triangle. Here our next class is square. Figure publicly, the square class is publicly derived from the base class, and what is square? We see that this is rectangle or square which contains length and width. That's why it is square. This is length and this is width. Square dimensions are x cross y. Value of x, the value of x is 12 and the value of y is 6. Then 12 cross 6. This will be the dimension, and it is length into width is the area of this square or this rectangle. So we will calculate it with this expression, x into y. Area of rectangle x into y. Area of square x into y. Show area is the function of this square class. Show area is also the function of this triangle class. Show area is also the function of this base figure class. Show area. This is virtual. It has no functionality here, but the triangle class has show area function with its own functionality. This functionality is totally different from the show area function of square class, whose functionality is x cross y. X cross y is the functionality of square class show area method or function, which is different from the previous one. Here we have another class named circle class, which is publicly inherited with the figure class, and the show area method. This figure circle class also contains an area show area function with the same name as that of the triangle or square and the figure class. And the functionality of circle area. Circle area is calculated with pi r square, that is the square of radius. Pi r square is the actually the formula for calculating the area of circle, and this x is denoted the radius, r into r or x into x. This denotes, because s denotes the radius, radius into radius square. This is the value of pi, 3.14. Pi r square. This is the formula for calculating the area of radius. This functionality is totally different from the area calculation functionality of square or area calculation functionality of triangle. So this show area, the name of the function is same, but its functionality is different from the other two figures, that is triangle and square. Here we have main program coding, void main, the base class. For creating the runtime polymorphism, we need a pointer of the base class. Figure is the base class and star p is the pointer of this class. P, its own address is 100 and its memory is this one, this is a pointer. It will hold the address of different objects, that is T, S, and C. T is the object of triangle class, S is the object of square class, C is the object of circle class. So all these classes, because all these classes are inherited with the base class figure, and base class figure contains two attributes, X and Y. So T will have two attributes, X and Y. S will have two attributes, X and Y, and C will have two attributes, X and Y. Here, when the computer will execute these 4 lines of main program, it will create the memory, that is a pointer and 3 objects. Further, when the main program will execute the next line, that is this one, P is equal to NT. It means the address of T. What is the address of T? It is 200. 300 is stored in P. We are assigning the address of T to P, so 200 has been stored in the memory of P. Here you may see 200. Now P will call the setDim function. P contains, now P is representing or pointing the object T. You may see that T is calling the setDim function, but there is no setDim function in the triangle class. So it will transfer control to its base class and will call the setDim function of its base class. So when this line of code will execute, it will jump to the setDim function of its base class and will pass the value of 10.0 and 5.0. X will receive 10.0 and Y will receive 5.0. So here you may see that this pointer contains the address of triangle class object T, and here void setDim function will execute, and here I is the local variable which contains 10. The value 10 passed here, passed to the setDim function. So I will receive 10 and J will receive 5. You may see it here. I received 10 first value and J received value 5, which is stored in the memory of I and J, and this I receive its value 10 and assign this value 10 to X, and the J assign this value 5 to Y. So when the control, after execution of this function, control jump back to main program, the XY of the T object contains value 10 and 5. You may see it here. The X and Y object of X and Y attribute of T object contains 10 and 5 value, because this pointer contains 200 address and it has stored the I and J value at the X and Y location of 200 address. This is the 200 address, and at X and Y location it has stored the J, I and J value, that is 10 and 5. After that, computer will execute P show area function. Because P contains the address of T object, so it will call the show area function of T object. Sorry, because 200 is the address of T object, so P show area will call the triangle class show area. This is our triangle class, which is publicly inherited with the base class figure, and this pointer contains 200 address of T object, and from this address it will fetch the value of X and Y and will show here. This is the output. The value at 200 address is the X is 10 and Y is 5. So computer will display here the value of 10 and 5. By show area will execute, and the first line is triangle with height X. What is the value of X? That is 10, and base Y, that is 5. Triangle with height 10 and base 5 has an area of X multiplied by 0.5 multiplied by Y. This thing will be shown at the next line here like this, because backslash n is here. So has an area will be the area of this a message will be displayed at the next line, and computer will calculate 10 into 5. 10 5s are 50, and 50 divided by 0.5, that is 2. It will be 25, so it will display here 25. After showing this output, show area, the execution of show area shows this output, and after execution this output, computer will jump back to main program and it will execute the next line. Here p is equal to and s. What is the address of s? Address of s is 300. This address is going to store in p. P contains 300. Now p is set dim. P will call set dim, but p contains the address of 300. We can say that 300, that s is calling setdim, but there is no setdim in the square class. Setdim is exists in the base class figure, so it will call the setdim of the base class. This function will call the setdim of base class. This is the base class, and setdim function is called by the s objects, that is square class object, and it has passed the value 12 and 6. You may see it that setdim 12 is passed to I, 6 is passed to j. So I contains 12 and j contains 6. So I and j value is stored in the memory location of x and y, and this x and y belongs to this address. So after execution of this function, when we will jump back to main program, at 300 dash we will see the value of 12 and 6. You may see it here. At 300 dash in the memory of s object, x contains 12 and y contains 6, while still c does not contain any value because we have not executed or we have not manipulated this memory. Next is the p show area, because p contains 300. So s object is trying to call show area function. This show area belongs to the square class. So square class, because p contains the address of s object, so s will call the show area of its own class, that is square class. This is square class. It is publicly inherited or derived from the figure class, and this pointer contains the address of s object. So show area will access the value of x, that is 12, and the y, that is 6, from this address, and will show here at this position. X will show 12 and y will show 6, and here computer will multiply the value of x, that is 12, with the value of y, that is 6, plus 6 is 72. So first line will display the dimension, that is 12 cross 6. So it has displayed 12 cross 6 here, and the next line \n will transfer the control at the next line, and it will display has an area of x cross y, that is 12 into 6, 12 6 is 72. It will display first the message has an area of, and then the value 72 by calculating this formula. After displaying this output, the control will jump back to main program, and here the next statement is p is equal to and c. Now c wanted to manipulate its memory, so address of c is 400, and c means address of c. 400 is assigned to p. P contains 400 now. Now it is pointing to c object. Firstly it was pointing to t object. Now it is next it pointed the s object. Now at the last it is pointing to c object. That is why it is called pointer. It contains the address of different kinds of object one by one. So and c is stored in p. Next, when we p will call setdim, because p contains the address of 400, we can say that c is calling setdim. But there is no setdim in the circle class. Setdim belongs to the base class of the circle class. So base class of circle class will be called 9.0 is single value. So single value will be passed to the base class. This I will store the value 9. The first 9 9.0, the first value. There is no second value, so default j is equal to 0. It will store. If we do not pass any second value to this function, then the second variable will get the default value, that is j is equal to 0, and it will store j is equal to 0 in its memory. Here the value of x, I is stored in x, and the y is stored in j is stored in y. So at 400 address, the x will contain 9 and y will contain 0. We go back to main program and we see at 400 address the x contains 9 and y contains 0. After that, this statement will be executed, p show area, because p contains the address of C object. So we can say that C is calling show area. In the circle class show area, control will jump to circle class show area. This is circle class, this is publicly derived with the base class, and this show area will jump to this address for accessing the value of x and y. So here this function is only using the x value, because we say that the value of x represents the radius of the circle. So circle with radius value x, that is circle with value 9.0 has backslash n jumps to next line, has an area of 254.34. When 3.45 will multiplied with the value of x, that is 9, and this 9 will be multiplied with again with 9, then the value is calculated as 254.34. This is the area of the circle. This is different functionality from the area calculation of square, and the area calculation of square is different from the area calculation of triangle. So when the control will jump back to main program, you see it here that this portion is calling different kinds of function, but you see that there is no difference. P minus symbol, greater than symbol, show area, parenthesis and semicolon. This statement, this interface is same way like this, and this interface is same like this, but this is the same interface, but this same interface is performing different functionality. That is why we define the polymorphism. That polymorphism means one thing. This is one thing with several distinct forms. It jumps to different show area functions, that is triangle class, square class, circle class. This is called different forms. Or we can say that one interface, multiple method. One interface method function, the function is also called the method. There are different methods which are accessed through this command, this command, this command. Command is same, but the functions are different. That is why multiple method. Same interface, one interface, multiple method. That is, a general class of operation can be accessed in the same fashion. General class of operation. Class of operation. More than one functions or method or operations are called class of operation. So that general class of operation is accessed with the same fashion. This is called polymorphism. In the next section, we will use pure virtual function. In the pure virtual function, a virtual function that is not overridden in a derived class is called for an object of the derived class. The version of the function as defined in the base class is used. We defined the multiple functions in our derived classes, and the same function is also redefined in the base class. But if the base class function has its no body, but it is just providing the same interface for different classes, then such a function is called pure virtual function. However, in many circumstances, there is no meaningful definition or coding, that is message coding, etc., of a virtual function. In a pure virtual function, we cannot see any meaningful definition. That is, the body of the virtual function is empty inside the base class. For example, our program, which contains figure, rectangle, triangle, and circle names, as its class name as its class name. In this program, the class figure is base class. In this class, the definition of show area is simply a placeholder. We can see it here. The coding of show area is just a placeholder. We can, we write it like this. Let's pause. If we write it like this, we do not use the body of this function. We delete the body and just we write here is equal to 0 and then semicolon. Then this function which have no body, no area computation in it, then this show area, if this show area definition exists in the base class, such a definition is called pure virtual function, that it is not performing any duty for its base class, but it is just performing the same interface to its derived classes. This is the syntax of our pure virtual function, and you may see it here. Here, it is just a placeholder. Pure function just perform the function of placeholder, not to perform any kind of functionality for its base class. It does not compute and display the area of any type of object. Its coding consists on some message which is not very important. Therefore, it is required that the object of this base class should not access this virtual function. So, base class object cannot access that virtual function which is pure. It should not work for any derived class, and it cannot work if derived class has no version of its own. Then that pure virtual function will not work for any kind of operation for its derived class, which does not contain its own version. If the derived class does not contain its own version of that function, the pure virtual function of the base class will not work for that derived class. It should only play the role of interface for distinct function, of the derived classes. Pure virtual function does not play any role for its own base class, but it plays the role of interface for distinct functions. Same interface for different functions. Keeping in mind the above points, we define a pure virtual function is a function declared in base class that has no definition relative to the base class, which we have seen in our example, that if the function is just like this, it has no definition for its base class. Then, since it has no definition relative to the base class, and derived class type must define its own version, derived classes will define their own versions of that function. It cannot simply use the version of defined defined in the base. The general form to declare a pure virtual function is as follows: virtual, the type, that is void, integer, float, etc. The function name as show area in our previous example. The parameter list, if exists, is equal to 0 and then semicolon. We have shown it in the previous slide, where virtual is the keyword. This virtual is the keyword. Type means the type of return value. Void, integer, float is this type mean, that is it. Here we can write void, integer, float. And function name, this is the name of the function, whether show area, display, etc. Parameter list means the receive variable, how many variables or which kind of variable a value is received. Parameter list means this. This was the end of our lecture number 24. Allah Hafiz.